Hello students, welcome to my channel Science No Problem. My name is Tish Kumar Sharma and I am teaching you science. So my dear students, like our previous videos, this video is also going to be very informative and very useful. So please watch the video till end and please don't forget to like, share and subscribe our channel to motivate and support me so as to bring you far more useful and far more informative videos in future as well. So my dear students, as you know, we have started a series of most important questions which can be asked in exams. So my dear students, this is our second video of the series of most important questions of chapter metals and non-metals. So let's start so please watch the video till end. So let's start our today's video. Our first question is, explain how mercury is extracted from its sulfide ore cinnabar. Cinnabar is, my dear students, mercury sulfide. Always remember, mercury sulfide is cinnabar. So how we can extract mercury from this? Give equations of reactions involved. So we have to extract mercury from cinnabar, that is mercury sulfide. So my dear students, always remember that we use a process known as roasting to convert this mercury sulfide into oxide. So how we do that? Let's see here. Mercury sulfide is heated in presence of oxygen, and my dear students, this process is called roasting. So always remember that sulfide ores are converted into oxides by heating them in presence of oxygen, and this process is known as roasting. So please remember this is very important process. So it will change into mercury oxide plus sulfur dioxide. After that, my dear students, now we will decompose this mercury oxide. So mercury oxide, that is called, actually removal of oxygen is known as reduction. So we will do the reduction of mercury oxide just by heating. So we will heat this and this will change into mercury plus oxygen and mercury gets extracted. So this is how to answer this question number 1. Now we have second question. What is second question? Explain the formation of ionic compound calcium oxide with electron dot structure. So my dear students, always remember calcium oxide, that ionic compound, this is ionic compound. Always remember that ionic compound is always made up of metal and non-metal atom. And always remember that metal atom gives electrons and non-metal atom takes up electrons. So with this information, we will draw its electron dot structure. So my dear students, calcium and oxygen. So what is the electronic configuration of calcium? Atomic number of calcium is 20. So it's actually K, L and M. In first shell 2 electrons, 8 and 2, 8, 18 and 20. So and in oxygen, atomic number of oxygen is 8. In K shell 2 electrons, in L shell 6 electrons, and in calcium, in outermost shell we have 2 electrons, and in the outermost shell of oxygen we have 6 electrons. Always remember, my dear students, it is the electrons of outermost shell which take part in bonding. So 2 electrons of calcium and 6 electrons of oxygen, so they will take part in chemical bonding. So 2 electrons I can write like this, and here is 6 electrons. One 2, 3, 4, 5, 6. Now actually calcium will give its 2 electrons to oxygen. So how we will write this? So when calcium will give 2 electrons, it will acquire 2 plus charge. And when oxygen will take up 2 electrons, so it will have now 8 electrons and it will acquire 2 minus charge. So there is bonding between now actually there is attraction between positive and negative charge, and due to that attraction ionic bond will be formed. So we can write like this. So this is electron dot structure for calcium oxide, this ionic compound. So I think you understood this question. Second part is name the constituent metals of bronze. My dear students, always remember that bronze constituent metals of bronze are copper and nickel. So please remember this, copper and nickel. Question number 3. Which method given in column 1 is applied for oxidation of ores given in column 2? Give 3 points of difference between these processes. So my dear students, in column 1 we have two processes are given, roasting and calcination. So my dear students, always remember that roasting is done of sulfide ores and calcination is done of carbonate ores. So roasting will be done of zinc and copper, zinc sulfide and copper sulfide roasting, and calcination will be done of calcium carbonate and lead carbonate. So always remember that roasting is done of sulfide ores and calcination is done of carbonate ores. And what is the difference between roasting and calcination? Roasting means heating in presence of oxygen, and calcination means heating of ore in carbonate ores or in absence of oxygen. Second difference is that in roasting sulfur dioxide gas is produced and in calcination carbon dioxide is produced. Third point, you can say that roasting is done for to extract to convert zinc to convert sulfide ores into oxides, and calcination is done to convert carbonate ore into oxides. So this is how we can answer this question. Now we have question number 4. Give reasons. We can store copper sulfate solution in silver vessel. My dear students, listen this question carefully. We can store copper sulfate solution in silver vessel. So in terms of reaction, chemical reaction, how we will write? Silver plus copper sulfate. So my dear students, if you remember actually the activity series, then you can remember that silver lies below copper. So copper cannot displace silver cannot displace copper. So there is no harm in, so copper sulfate and silver will not react. So there is no harm in storing copper sulfate solution in silver vessel. But silver nitrate solution, but not silver nitrate solution in copper. Silver nitrate solution we cannot store in copper, Why? Because copper plus silver nitrate. So copper is more reactive, so this will displace silver from silver nitrate. So actually copper and silver nitrate will react. So we cannot store silver nitrate solution in copper vessel. So I hope that you understood the answer of this question. Now second part is state the reaction of zinc with dilute nitric acid does not produce hydrogen gas. This is the question. Once again, the reaction of zinc with dilute nitric acid does not produce hydrogen gas. So we have to give reason. Yes. Now my dear students, always remember that nitric acid is oxidizing agent. Nitric acid is oxidizing agent, and always remember that when metals react with mineral acids like sulfuric acid, hydrochloric acid, nitric acid, so which gas is produced? Hydrogen gas is produced. So what happens in this case when zinc will react with nitric acid? Hydrogen gas will be produced, but as soon as it will be produced, hydrogen gas, actually nitric acid will also actually give oxygen. So that oxygen will actually reacts with combines with that hydrogen to form water. So hydrogen gas is not produced here when zinc reacts with nitric acid, because nitric acid is oxidizing agent. It will actually give oxygen, and the hydrogen which is produced in the chemical reaction will combines with oxygen to produce water. Then we have next question, third part. Food cans are coated with tin rather than zinc. Once again, food cans are coated with tin rather than zinc. Why food cans are coated with tin? Because tin is not so reactive as zinc is. So food food items will not react with tin because tin is less reactive. And if food cans are actually coated with zinc, then the food kept in these food cans will react with zinc because zinc is more reactive. So we cannot actually store food in zinc coated cans. Next is fourth part. Most metal oxides are insoluble in water, but some of these oxides are soluble in water. What are they called? So my dear students, the metal oxides which are soluble in water, metal oxides are, always remember that they are basic in nature, and the metal oxides and bases which are soluble in water are called alkalis. So our answer is alkali. Some alkali metals can be cut with knife. Yes, because for example sodium and potassium, they can be cut with knife. Why? Because they are highly electropositive. So due to being highly electropositive, they are soft, so they can be cut with knife. The next question is, when calcium metal is added to water, the gas evolved does not catch fire. Once again, when calcium metal is added to water, the gas evolved does not catch fire, but the same gas evolved on adding potassium to water catches fire. Why? So my dear students, the answer of this question is this, that calcium when added to water will not catch fire, and when potassium will be added to water, then actually this will catch fire. Potassium will catch fire. Now calcium is actually less reactive and potassium is more reactive. So the reaction between calcium and water will be less violent reaction. So the heat produced in the reaction is not sufficient to to catch fire. The heat produced in the reaction is not sufficient that hydrogen gas will catch fire. And in this case, actually, when potassium reacts with water, lots of heat is produced. The reaction is very violent, and lots of heat is produced, which can actually ignite hydrogen gas. So this is the answer of this question. Now, my dear students, we have next question, question number 6. First part is define corrosion. So, my dear students, in simple terms, how will you define corrosion? Corrosion is a process in, in which metals are slowly eaten up by substances like moisture, air, acids. So, this process is known as corrosion. Second part is, what is corrosion of iron called? So my dear students, always remember that corrosion of iron is called rusting. How will you recognize the corrosion of silver? So we can recognize the corrosion of silver by a black coat deposited on silver articles. Fourth part is, why corrosion of iron is a serious problem? Because actually a lot of money has to be spent in order to replace damaged iron or rusted iron. So that is why this is a serious problem. How can we prevent corrosion? Corrosion can be prevented by, for example, oiling, by greasing, by painting, and there are techniques like galvanization, anodizing, so or by making alloys. So through all these processes, corrosion can be prevented. Our next question is, write the names and symbols of the two most reactive metals. So we can you can write, my dear students, two most reactive elements, potassium and sodium. So explain by drawing electronic structure how any one of the two metals reacts with halogen. Explain by drawing electronic structure how any one of the two metals reacts with halogen. Okay. Now, my dear students, actually we have to write the chemical equation between, for example, we are taking sodium plus halogen. Always remember that fluorine, chlorine, iodine, bromine, these are called actually halogens. So I am taking actually chlorine. So my dear students, this is sodium. Sodium is metal, chlorine atom is non-metal. So the actually compound which will be formed will be ionic. So actually sodium, what is the actually electronic configuration of sodium? Sodium atomic number is 11. So KLm 281, and chlorine 17, KLm 287. So you know it is the outermost electrons in outermost shell which take part in bonding. So these will take part in bonding. So one electron. Chlorine, how many electrons in the outermost shell? 7. 2, 4, 6 and 7. So my dear students, always remember that ionic bond will be formed here. And metals, they always have tendency to give electrons, and non-metals have tendency to take electrons. So sodium, in order to have 8 electrons in their outermost shell, or we can say to achieve noble gas electronic configuration, they take or give electrons. So to have 8 electrons, it will give 1 electron to chlorine atom, and then sodium will have 8 electrons in its outermost shell, and chlorine will take up 1 electron, it will also have 8 electron in its outermost shell. So Sodium will give electrons, so it will acquire positive charge, and chlorine will take one electron, it will acquire negative charge. So ionic bond will be formed between these opposite charges. So this is how actually ionic bond is formed between sodium and chlorine atom. State any three physical properties of the compound formed. So my dear student, this is ionic compound. Ionic compound is formed. So properties, physical properties, for example, melting and boiling points of ionic compounds is very high, and they are soluble in water but insoluble in organic solvents, and they conduct electricity in solution form. So these are the physical properties of ionic compounds. So my dear students, I hope that you understood all the questions, answers of all the questions which we have discussed. So this is all for today. So if you like this video, then please like, share and subscribe our channel. And thank you very much for watching this video. Keep watching our channel, keep learning and keep growing. Thank you.